Hey, let's talk about inverse functions. Now, as with most of the things that we've been doing for the past many months, this is a new idea. And very likely you haven't heard about an inverse function, but let's take a look. I'm confident you'll be able to understand, but again, there's going to be some new ideas starting with, honestly, our first fact. You see, inverse functions, if f and g are inverses, now look, we've got some notation already. This little f negative 1, when you see that negative 1, that means the inverse of f. F negative 1 means the inverse of f. So the inverse of f is g, which means that f and g are inverses. Then all the x values of f, all the x values of f will switch to be the y values of g, and vice versa. X values switch to be the y values, and vice versa. Let's see if we can apply that. Let's see if we can apply that idea, this inverse switch fact, to help us draw a sketch of the inverse of this graph. Now, this graph right here, this is the f of x graph. And what we're trying to do is we're trying to come up with the inverse graph. Now, it sounds like we got to do some switching of x and y values, so maybe it would be helpful if we just figure out some x and y values, which is exactly what I'm doing first. I'm basically finding the x and y values of these points. So we're writing these points with x and y values. But I'm doing this because soon what I'm going to do is switch them. What do I mean switch them? Well, we're going to switch 2 and 5 so that the y value becomes 2 and that the x value becomes 5. What does that mean? Well, that's going to be the point 5, 2. See how I did that? I switched, and now I have the point 5, 2, which conveniently would be right here. What happens if I switch these? I switch the x to be the y and vice versa. That's going to give me the point 2, 1. The point 2, 1, which is going to conveniently be right here. Are you still switching? Keep switching. I just realized that I mislabeled this point right here. This is 0, 1. Sorry about that. That's 0, 1. But if I switch it, it becomes 1, 0. If I switch this one, I get 2, negative 1. 2, negative 1 is actually in this spot. And if I switch the last one, I get 5, negative 2. And of course, 5, negative 2 is right here. Now, there's a lot of writing on the page here. There's a lot of writing, but I want you to realize that we now have 5 new points. And these 5 new points are in a particular shape. And if maybe we get rid of some of the extra stuff here, we can see that the shape that we've created would now be this direction. And guess what? That is the inverse. That shape, that graph that you just drew, that is the inverse graph. And all I had to do was switch all the x and y values to get that new graph. Now, there's something special about this new graph. Yes, it's the inverse, but it also kind of looks like the original graph, but it's a reflection of the original graph. It's a reflection over this line. You see, that diagonal line kind of splits the two graphs in half. It's the reflection line. It's the line y equals x. It's a perfect diagonal line. And sometimes I'll tell kids, although it's hard to do it on the video here, but if you fold over that diagonal line, the two graphs will be right together. That is why a function and its inverse will always be a reflection. A reflection, a fold. They kind of look the same on both sides of that line. So that's our first inverse idea. The idea is that you can switch x and y, and you will get a graph that is the reflection. Ready for some more? Yeah, what about if we try to find an inverse? If we try to find an inverse, that is, find it more like an equation. Well, you're going to find out that you still switch x and y. That's actually the key part to any inverse problem. But we're going to switch x and y in the equation. And then you're going to solve for y. You'll see. It'll kind of make sense. It'll feel like it's the right thing to do. Now, look at the equation that we have here, x squared plus 1. Listen, that's the graph. That's the equation of the graph that I started with up here. So it's still the same problem, but it's the equation now. Now, when you have f of x equals x squared plus 1, that's the same thing as y equals x squared plus 1, right? We can write it with the letter y. It would be y equals x squared plus 1. But why did I do that? Well, so that I could switch x and y. Literally, I'm going to use an x where the y was, and I'm going to use a y where the x was. I just switched x and y. Okay, but you see that I did that in the equation. Now, that equation looks a little sort of different. Yeah, that's because it's x equals. Normally, we like equations to be y equals. And so now what we're going to do is we're going to solve this equation for y. How do you solve the equation for y? Just do a little bit of subtract 1 from both sides. Just do a little bit of take the square root of both sides. Now, when you take the square root of both sides, you get plus or minus. And your result is y equals. That's because we're trying to solve it for y. So it's y equals plus or minus the square root of x minus 1. What is that? What is y equals the square root of, the plus or minus the square root of x minus 1? Well, it's the inverse. It's the inverse of what I started with. And that equation actually will be this graph. Do you believe me that the plus or minus the square root of x minus 1 is that graph? It's something that we could check out on Desmos. Shall we? Yeah, let's check it out. So, tell you what, while we're on Desmos, we can also kind of check out our original equation. This was the one that started on our paper. It was the y equals x squared plus 1. It was a parabola. And then what did I want to do? Yeah, I wanted to graph y equals plus or minus. Y equals plus or minus. Is there a plus or minus sign here? Doesn't look like there is. So what I'm going to have to do is I'm going to have to graph two equations. I'm going to graph the positive equation, and then I'm going to graph the sort of the negative equation. That's how you do a plus or minus. It's okay. But you see what's happening here? Yep, we're going to end up with that second graph that we created. We're going to end up with the inverse. And if you really want to, you could graph y equals x, that diagonal line that goes, that cuts right through the middle. So, we have our inverse equation. It's plus or minus the square root of x minus 1. We have our inverse graph. Our inverse graph has the reflection. And the whole idea here is that they all go together. Now, there's a little problem with our inverse graph. It's not wrong, but there's a function problem. You see, if you think about vertical lines, remember the vertical line test? Yeah, if you think about vertical lines, it's going to end up touching the graph at two places. Okay, that's not good. That's not good, at least that means that it's not a function. Not a big deal, but it's just something else that we add to our answer. We say that the inverse is not a function. Again, because the vertical line test sort of fails miserably. Let's see if we can find some more inverses. We're going to find the inverse. And this is a little bit more of the algebra equation part of this lesson. That just means I'm going to switch x and y, right? We're just going to switch x and y. So wherever y was, we put the letter x, and wherever x was, we put the letter y. But now my equation looks kind of strange. Well, that's because it's not y equals, but I can make it y equals if I just start solving it for y. So we'll do a little subtract 4 from both sides, and we'll do a little divide by -3 to both sides. Now when I divide by -3, I can divide both of these by -3. That just gives me 1 over -3 times x plus 4 over 3. It's just a little different. You kind of simplified it. But the whole point here is that that equation is our inverse. That's our inverse equation. So we'll label it that way. Now, is this equation a function? Is the inverse a function? Okay, well, we don't have a graph, but we can think about the graph. And to think about the graph of this equation, I hope you're thinking about a straight line. A straight line that has a slope and a y-intercept. Listen, a straight line that has a slope and a y-intercept is always going to be a function. So yeah, the inverse is a function. Do you want to see these two graphs on Desmos? Do you want to see that they really have the reflection? You don't? Well, let's take a quick look. I'm just typing in the original graph. It actually is also a straight line. I'm now going to type in the inverse graph. Carefully typing in the inverse graph, I end up with another straight line. It's a little bit harder to see the reflection when you have straight lines, but it is true that these two graphs kind of look the same, if you will. They look reflected, they look folded on both sides of the diagonal line. And if you really want to go for the jugular, you can find some points. Like a point that's on the original graph, 0, 4. And a point that's on the new graph, 4, 0. What's so special about those 2 points? They're switched, right? 0, 4 switched to be 4, 0. And we can actually find this is true for other points, just so you can see one more point. -2, 10 on the dark graph, the black graph, switches to be 10, -2. 10, -2, if I can get it to stop. Okay, so anyway, that is a good sign that my answer is right. Let's try another one. Let's see if we can find the inverse. Now, f of x, remember, f of x is the same as y. Do I have to really rewrite that as y? I don't really have to do that because I know I'm going to switch it to be x. I'm going to switch it to be x. And I know I'm going to switch x to be y. So we switch x and y. Now, after you switch x and y, you got to solve the equation for y. As you can see, y is kind of hidden in here. Why don't we take the square root of both sides first so that we can start to undo this equation? Now, as soon as you take the square root of both sides, you get a plus or minus. And then all I got to do is deal with that plus 5, which you're going to subtract from both sides. So I get plus or minus the square root of x minus 5, and that's equal to y. And since that's equal to y, that's going to be my inverse. I'm going to label it as the inverse. I'm going to use the notation. So I get plus or minus, the inverse equaling plus or minus the square root of x minus 5. Now again, we don't have a graph. We could make a graph if we want, but if you think about what happened up above, as soon as you get that plus or minus, you kind of get like both sides of the graph. And if you think about the vertical line test, you're going to have a fail. You're going to fail the vertical line test, so it's not going to be a function. I'm going to skip graphing that one on Desmos. Let's go to the last one here. Y equals negative 8. Wait, I'm supposed to switch y to be x? So just x equals negative 8? Is that all this is? Well, actually, yes, that's all it is. But is it right? Is there something we're missing here? For this one, let's think about the graph just manually. So how do you graph y equals negative 8? Well, remember, that's just going to be a horizontal line down here at negative 8. How do you graph x equals negative 8? Well, remember, that's just going to be a vertical line over at negative 8. If you think about a diagonal line, of course, the diagonal line y equals x, do these two graphs have reflection, have a fold? Well, yes, they do. Yes, they do. In fact, you can even see that this point right here on our inverse graph, by the way, that's the point negative 8, 0, switches perfectly to be this point right here, 0, 0, negative 8. And so all the points are doing this, even though we just have straight lines. So yeah, our answer, just to emphasize, our answer is x equals negative 8. Is it a function? Is this vertical line a function? No, it's not a function. It fails the vertical line test. Ready for a little bit more? I told you this is going to be new. There's a couple new ideas when it comes to inverse functions. We have something called the horizontal line test. Wait a minute. I thought we had the vertical line. No, this is the horizontal line test. What I ask students to do here is just to read. And so let me ask you to do the same thing. Just read about the horizontal line test. And then I'll meet you back here in a second. After you read it, make sure you look at the examples they're showing down here. Now, let me highlight some things literally. To decide whether the inverse of relation is a function, so this is a test to see if the inverse is going to be a function, you're going to use the horizontal line test. If a horizontal line passes through one or more points of the original graph, you see, this is the whole kind of point to this. You do your test on the original graph. Then the inverse is not a function. You see, it's a test that you apply to the original graph so that you know what's going to happen with the inverse graph. So how about our first one here? Does it pass the horizontal line test? Yes, it passes. So that means the inverse is a function. How about this one? Does it pass? No, it doesn't pass. It touches at 3 points. That means the inverse is not a function. So when you use the horizontal line test, you're using it on the original function, but it's going to tell you what's going to happen with the inverse function. Horizontal line, does it pass? No, it touches at more than 1 point. That means the inverse is not a function. How about this one here? Does it pass the horizontal line test? Now, when I say pass, that means that it's only going to touch at 1 point. Looks good. That means that the inverse is a function. So the horizontal line test allows us to understand what's going to happen with the inverse graph without actually graphing it. One more thing. What if I ask you to do the inverse of a set of ordered pairs, of basically numbers? Well, it's actually what we kind of did in the very first step on the front, where we had points. And what do we do with those points? That's right, we just switched them. We actually switched all of them. And as you switch those points, you're creating the inverse. So now we have 0, -2. Now we have, I'm going to have to zoom in here a little bit. Now we have 0, -2. Now we have 3, -1. Now we have 6, 0, and 9, 1, and 3, 2. Now, all I really did there was I switched all the x and y's. But do I still have, or do I now have a function? What does that mean? Well, look, if you look at this x value of 3, it goes to a y value of -1. But if you look at this x value of 3, it goes to a y value of 2. That's not good. That's not good because I have x3, that is the number 3, going to 2 different y values. And remember, that means that it's not a function. Now, you might think that the inverse is never a function. Well, be careful, that's not true. Okay? Sometimes the inverse is a function. It all depends on your x's and y's. But here I notice that when I switch x and y, my resulting list of points is not a function. Well, I have a variety of problems for the homework. You're going to do some switching, you're going to do some graphing, and maybe you'll just kind of put a few ideas together. Please make sure that you look at this. It's a new idea and it's going to take some work. We're going to keep working on it tomorrow. But for now, that's all we got.